Welcome guys, today's video is on scientific notation. Now the purpose of scientific notation is to rewrite numbers in a manner in which we can understand them. And by numbers I mean either really big numbers or really small numbers. So let's say you're writing and you want to talk about the distance between the Earth and the Moon, or say the Earth and Pluto. Okay, those are massive numbers, even if you use the biggest measurement of distance you could. Or let's say you're a doctor and you want to talk about the distance between, an atom or the size of an atom. Okay, that's going to be a really small number, hard to write and very time consuming to write. Scientific notation condenses them so that it's easier to write and easier to read. On this slide is everything I said on the title slide. The only other thing I want you to notice is that you can also use scientific notation for calculations. What's the point in writing big and small numbers if you can't do math with those numbers? So we'll get to that bit at the end of the PowerPoint. But for now, the way you write scientific notation is in the form of a times 10 to the n, where a is your number, and we'll talk about what n means on the next slide. So here we go. Now, when you're writing scientific notation, remember, we're condensing or we're rewriting really big numbers or really small numbers. So there usually is a decimal point. And this decimal point will either be at the end of a number or somewhere in the middle or even in front of the number. I'll show you some examples on the next slide. But what you're going to do is you're going to move this decimal point until it is to the left of the first non-zero digit. Okay, that will give you a real number for the letter A. And what I mean by real number is, like, you can't have pi, okay, be the symbol of A. It has to be a real number. Now, n is the number of times and the direction that the decimal moves in. So, whenever you're doing scientific notation, you want to pay attention to how many places the decimal point moves and in which direction, left or right. If it moves left, so if you're moving the decimal point left, that means you're going to write the number as a times 10 to the n, where n is positive. Okay. If you're moving it to the right, then you're going to write it as a times 10 to the negative n. Then lastly, you're going to remove all unnecessary zeros. Because remember, these are really big numbers or really small numbers that we're dealing with. There's going to be a lot of zeros to serve as just placeholders. But since we're rewriting the number, we don't need those placeholders anymore, so you can get rid of them. All right, make sure you have this down. We're going to do a few examples, and sometimes certain concepts in math are easier to see after the example. And here we go. So in this first example, I have a really big number. So first off, I'm going to move my decimal place over until it's to the left of the first non-zero number. So I can't stop. I can't stop here and I can't stop here. All right, 1 is not my first non-zero number. 2 is my first non-zero number. So I'm going to move my decimal place over 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, I moved it 8 times and I went left. So when I rewrite it in scientific notation, I'm going to have 2.01 times 10 to the positive 8. Because remember, when you move the decimal place left, n is positive. Now, when I go to example B, again, I have to move it to where it is to the left of the first non-zero number. So I'm going to move my decimal place. It already gives it to me. 1, 2, 3, 4, 5 places to the right. So then I'll rewrite this as 5.1 times 10 to the negative 5. Because remember, when it goes to the right, n is negative. Last thing I want you to pay attention to on both of these slides, notice how I dropped all my extra zeros. Okay, I didn't need them in either picture or in either example. Scientific notation is basically you writing the essential information in a condensed form. So here are my non-zero numbers. Okay, this 0 just gets lucky because it's included in between two numbers. And then up top, here is my number of places moved. Meaning, of course, your decimal point. Now remember, in math, if you can go forwards, you can go backwards. So if you can write numbers in scientific notation, well then you can rewrite them in their original form. Okay, so what you want to do in order to rewrite, go from scientific notation back to the number, is note whether n is positive. It's not how you spell that word. Positive or negative. Because that's going to tell you which way the decimal place is moving, the decimal point is moving. If n is positive, you're going to move it, positive, you're going to move it to the right. If n is negative, you're going to move it, I can't write today, you're going to move it to the left. Okay, so this is backwards. It's the opposite of what you did putting the number into scientific notation. So if you had a really big number, let's go the same one from the other slide. Close enough. If you moved it to the left to get it into scientific notation, then in order to get it out of scientific notation, you got to move it back to where it was in the first place. So if you move it left to get it into the notation, you got to move it back right to get it out of. Then you got to fill in or replace, we'll use that word. You have to replace your zero values. Because when you put it in scientific notation, we got rid of the zeros. So when you put it back into the normal number, you got to put them back as well. Here we go. So here's my first number. I have a positive 9 as my exponent. So that means I've got to move it to the right 9 places. So here I go. I have 6.32. And I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. And add my zeros. Your zeros basically go in each of the little bitty cups you made as you were counting backwards. Then rewrite it with proper commas. There's a comma that goes there, a comma goes there, and a comma goes there. As you may have guessed, it's a little hard, for me at least, to sometimes see the commas. That's why I usually have this middle step as almost my scratch work. It's probably not how you spell that word. Anyway, this is my first draft here. I can spell that one. This is my draft. Haha. And then I rewrite it as my nice, neat answer. Whenever you're on a test or a quiz, when I say show your work, I mean show that middle step where you have all your notes of moving the decimal place, adding your commas. That's your work. And then your answer has the commas included. Now let's go to B. I have a negative exponent this time, which means I'm going to be moving it to the left. My decimal point is behind the number. And I'm going to move it 1, 2, 3, 4, 5, 6, 7 places. Put in the zeros. And the nice thing about really big decimals is they don't have commas. So that would be your number. And this would, in fact, be your answer. All right. As promised, now that we have learned how to rewrite these numbers both as in scientific notation and put them back into their normal number form, let's get down to doing math with these numbers. Now, a number written in scientific notation is still, by definition, a number. And it's a number that has an exponent, which means that all the exponential rules still apply. So when you're solving equations dealing with scientific notation numbers, what you're going to do is you're going to separate the numbers into one category, and then the exponents are 10 to the exponent in the other. What that looks like is, since I'm multiplying these two scientific notation numbers together, first I'm going to pull out my normal numbers and put them up front. So 6.5 times 8.7. And then I have 10 to the 12th power times 10 to the negative 15th power. Okay. I'm going to multiply my normal numbers, same as always, and that's going to give me 56.55. And then I'm going to do my exponents. Now remember, when you're multiplying your bases together, you add the exponents. So that leaves me with times 10 to the negative 3rd power. Okay. So as of right now, we have a number that looks very, very close to scientific notation, except for one little thing. And that is that the decimal place is not in the right spot. If you go back and look at your definition of scientific notations, you'll see that in order for it to be properly written, the decimal place has to be behind the first non-zero number. So in this case, I have to move my decimal place over 1. Now, since I had to move my decimal place, that means my exponent also has to change to represent the fact that I moved my decimal place. Because remember, that exponent tells us where the decimal is. So since I moved my decimal place to the left, that means I have a plus 1 up here, because I moved it to the left 1. Well, negative 3 plus 1 is a negative 2. And this is your final answer. Make sure you remember to check for that at the end of your problems. After you simplify your normal numbers, after you get your first draft of an exponent, check and make sure that your decimal place is in the right spot. Then, whether you move that decimal place to the left or the right, make sure you add or subtract that number from the draft exponent to give you your final answer. Okay, let's do 3B. Now in 3B, we have power of powers. It's going to work the exact same way that it's done on all the other times we've done power of powers. Distribute your your exponent to the number and to your exponent. So when I separate this, I have 7.8 squared, and then I have 10 to the negative 4 squared as well. 7.8 squared is 60.84 times, and then whenever I have power of exponents, I'm going to multiply my exponents together, and that gives me 10 to the negative 8. Finally, I'm going to check and make sure my decimal point is in the right spot. Currently it's not, so I'm going to move it over 1 to the left, which means I add 1 up there. And this is my final answer. All right, that was multiplication. Now what about division? Because we can divide numbers too. Again, the same rules apply. You're going to pull your numbers off the side and divide those normally, or simplify them normally. And you're going to have your exponents doing the exponent rules. So when I do this one, I'm going to do 3.066 divided by 7.3. And then over here I have 10 to the 8 divided by 10 cubed. Since scientific notation is dealing with decimals, that means our answer is also going to be a decimal. So you're not going to leave your answer as a simplified fraction. It has to be a decimal. In this case, it is 0.42 times, when we divide our exponents, we subtract them. So 10 to the 5th power. Finally, I need to check and make sure my decimal is in the right spot. It's not. So I need to move it to the right one. Since I'm moving it to the right, that means I have a negative exponent. And so I'm going to subtract 1 from my draft exponent. And this is your final answer. And that's it. Please let me know in class if you have any questions, and I'll see you next time.